Hello, and welcome to the fourth episode in IOTA's FutureProof webinar series. At the IOTA Foundation, we are specialists when it comes to using new technologies to transform industries today. Through FutureProof, we want to share this knowledge with you. We're hoping that this will inspire new ideas and help you to understand how the Internet of Things and distributed ledger technologies can enable new business. We start each webinar with a presentation from one of our experts. At the end of each presentation, we will take 15 minutes to answer your questions from the chat right here on YouTube. I'm your host, Daniel Thompson-Ivoto from the engineering department at IOTA, and today I'm really happy to introduce you to my colleague, Jelle Millenaar, who works as a software engineer, focusing on digital identity at the IOTA Foundation. He studied game programming and computational neuroscience, and has been spending the past 6 months developing the IF's approach to making decentralized identity a reality, both technically, but also through consultancy and dialogue with our business partners. Indeed, that is what he will.
I've been working for the IOTA Foundation for a little bit more than half a year now as a software engineer with a specialty on digital identity. We've been developing our unified identity protocol for a little bit now, and I would like to introduce you to that. I'll introduce you to the basic concepts of digital identity first, then I'll deep dive into what it means to be a unified identity, and then we'll also talk about kickstarting the ecosystem of whole identity in general. All right, so digital identity, often called many different names such as self-sovereign identity, which is shortened to SSI, or DID, which normally stands for decentralized identifiers, is a concept to make a online representation of someone or something. For this, we use a standard proposed by the World Wide Web Consortium, or W3C. This is basically what a DID would look like. So DID stands for for the standard. Then IOTA is the distributed ledger technology used for a DID, and main would be the network which is being used. So this could be the mainnet of IOTA. DevNet could be possible as well, and then an IOTA address. And in total, this is really an identifier, and this can really identify anyone or anything. And that doesn't necessarily mean much, that you just have an identifier, but layers and layers will be built on top of that to add functionality to this. It's basically a initial unique identifier to really identify yourself. So an identifier such as a DID resolves to a DID document. This means that if you have the DID that you see here on the screen, and you would process this using the Unified Identity Protocol, it will find you a DID document shown here at the bottom. So a DID document contains more information about about the identity or the subject of this identity. What it contains is some standard stuff that we really don't care about. It contains the full DID. It also contains often a list of public keys. And the public keys are very important because that really allows you to prove that you're the owner of the identifier, or that you signed something as an identifier. And there can be one public key, you could have multiple public keys, and that really is up to you. The different key types that can be used can range from everything. We're not restricted to the normal set of IOTA, because this is a layer on top of the IOTA protocol. So for example, here we're using RSA encryption, but we've also implemented ECDSA for this. So that means that the protocol is very flexible, and we could add other encryption mechanisms later on. Besides that, the DID document also lists service endpoints, and these are basically URLs, and that can link to any type of data about an identifier. So you could think of a website which is associated to a company maybe it's an email address. You have to keep in mind that this DID document is actually posted directly to IOTA, so that means that you have to be GDPR compliant and not post any personal identifiable information in there. But this only is important for people, of course, because organizations and devices don't have any privacy rights like that. But yeah, the service endpoints can literally be anything. So it could also be an IOTA address with more information, for example. But a digital identity really becomes interesting when we start to look at another standard called verifiable credentials. And this is also a standard proposed by the W3C. And it's a very broad standard that allows you to add value to a DID. So let's describe what is exactly a verifiable credential. Well, I'll split it up into two words. So the credential is actually a statement about someone or something. And that someone or something is referenced by their DID. So the DID is included. And I intentionally left this statement pretty vague, like a statement can literally be anything, right? Well, that's true. It can literally be anything. So the type of statements you could think of can be very professional or very official, such as a driver's license. That is a very official statement. But it could also be a statement of endorsement where you say, well, I think that this person is really good with IOTA, such as like the LinkedIn endorsements. It could be even more friendly, like, hey, this guy is my best friend. It can literally be anything. But it becomes more important when you look at the verifiable part. The verifiable means that the information in that statement is backed by someone who signs it. So they use an electronic signature to say, I agree with this statement, and that puts their weight behind this statement. So, for example, a driver's license could be signed by a government and therefore put the weight of their reputation behind it, and therefore you can actually trust this driver's license, just like you would trust an actual physical driver's license because you know it comes from the government. But for example, I could create a verifiable credential which is signed by my mother that actually also states that I have a driver's license. But a lot of few people would trust that because it's not really an official party like that. And anyone can become that trusted third party. But yeah, to really make that happen, we need to combine this DID standard with the verifiable credential standard. And this is how that looks like. We basically get three roles. We have the issuer. This is a party that signs those statements. So they are the trusted third parties. So yeah, everyone could become an issuer, but it really depends on your reputation, where people accept your statements from. The holder is basically the subject of this information. So that could be myself, but that could also be another organization or a device, or even like a piece, just an object. And then we have the verifier. And the verifier is a party that would like to receive information from the holder and verify if it is actually true. So if I am speeding with my car and a police stops me and they say, please show me your driver's license, they are the verifier, I am the holder, and the Dutch government would be my issuer for that driver's license. And the holder and the issuer have their identities registered on IOTA because you need to be able to verify their public keys for that signature. While the verifier doesn't necessarily have to have an identifier for this. And this whole system is what we call self-sovereign identity, because a person can really be in control of their own identity. They can create it whenever they want, they can delete it, and they can decide who they share their data with. So they're in complete control, and that's the self-sovereign part of this. And here you see actually this exchange of verifiable credentials. So the holder here has this verifiable credential signed by an issuer, and the inspector can, the verifier can, inspect this information, see who signed it. Do I trust this party? It can decide that itself. And it will then also verify the signature to make sure that the party actually signed that and not someone pretending to be that party. So how is IOTA exactly involved in this process? Well, IOTA is basically the registry for all these DID documents. So all these DID documents are stored on IOTA, on their respective IOTA addresses, and you can really look up the public keys there. And since it's an IOTA address, we can send another transaction to the same address to update my DID document. So I could say, well, public key A is old. I want to replace it with public key B. And that any credential which I've signed with public key A would no longer be valid, because when someone tries to look up my DID document, they will find two transactions, one stating public key A is valid, the other one stating public key B is valid, but there's an order here. The one is published first, and the other one also references this, just like Master Authenticated Messaging, or MAM, does on IOTA. But IOTA is also used for the revocations. This means that when a credential which was signed before needs to be retracted, that is possible. So, for example, if after my speeding they tried to say, well, you no longer have a driver's license because, you were speeding too much, they could revoke my driver's license. And at that point, if I ever still show this copy of the verifiable credential that I still carry, and I show this to someone, that verifier will inspect it, will look at IOTA and see, hey, this is no longer valid, so I do not accept this driver's license. And this really makes sure that nobody can use old data. Another thing that IOTA can be used for are credential layouts and standards. So how should a driver's license look like? Like the Dutch government could have a standard and put it on IOTA. Maybe we can have a European-wide or even a worldwide standard for this. But it could also just be a standard within your organization for how you would like to see your data be laid out for specific credentials. And IOTA is a really good platform for all of this because we are public, feeless, and neutral. That means that there's nobody really in control of your identity. You don't have to pay anything for creating or using an identity. It's just a platform ideal for this. Nobody can take that role of like a Facebook, right? Where someone has power over other people's identities. It's completely neutral and everyone can use it. There's a small downside to IOTA, that's the snapshotting or sharding, where we delete a part of the DAG, the tangle, because we no longer see it as relevant. And if there are DID documents inside of there, they're basically lost for that particular node. Luckily, we've been moving forward with local snapshotting, where nodes can decide to store more data, and this problem is basically less of a problem for a longer time. And we also have our Chronicle Perma node now, which stores these things indefinitely. But obviously, this has scaling issues if we start to think in multiple years. So we have to think further than that, and we see like a community project as ION, which is a selective perma node that basically allows you to host your own data, or say, I want to keep this data on IOTA active and a relevant path to the current tangle, or like the latest transactions. And this basically proves that that this DID document has been embedded for a very long time on the tangle. And this proof can be just a couple of MBs instead of the gigabytes of the tangle that you would normally have to store to achieve this. All right, so a unified identity. Why did we call it like that? So most self-sovereign identity solutions really focus on an identity for people. That's the most common use case, and everyone thinks about that immediately. So how can that be used? Well, every time you fill in an online form on the internet, such as like, what is your address or what is your name, you continuously, repetitively put in the same information. And this is very annoying for you, so it would be really cool if you could just store that in a verifiable credential, which is signed by a trusted party. So my address or my name, I could have signed by my government. And I can just present this credential online. So when they ask this information to me, I just scan a QR code and then click, yes, I would like to share this data. And all these boxes are filled in automatically for me. So this is a better user experience for the people themselves, but it's also better for the organization because they actually can trust this data to be true because it is actually signed by the government instead of just randomly filled in by anyone online. So there's a big win-win situation here. You can use reusable know your customer. So every company that wants to enroll a new customer in their database, they need to do some research on their on this new customer if it's really who they say they are, if they really are who they say they are. And you do this with every single company that you sign up for. And often you have to fill in those online forms. So how cool would it be if you can just present like, hey, this is who I am, and you can really trust it because it's signed by the government or by a bank or whatever, or my insurance company. It depends on the information. And that allows you to sign up to a new service in a matter of seconds because I can present my information. They say, all right, we can trust you because they can verify this in seconds as well. And you can just click OK, and you now have an account. So there are more ideas. You can use it for self-sovereign data, such as healthcare data or electricity, where you take charge of this data. You store it in your own controlled environment. You sign it yourself, and you could then give consent to others to read this information. So this is, for example, very relevant in the time of this recording, as we're now in the corona epidemic. And yeah, healthcare data would be very nice to share. But I would like to have control over who I share this with. Like I don't want to give every single government in Europe access to my healthcare information, including like many companies for some reason. No, I want to decide, all right, the Dutch government can have access to my healthcare data and maybe some research bodies to make sure that they can learn from my data to better combat this disease. Um, so a verifiable CV can also be very useful. So you can imagine like LinkedIn, but all that information is proven. So the endorsements are signed, the work experience are signed by the actual employers, and that way when you're trying to hire someone, you can immediately see, all right, they have the diplomas they say they have the certificates they say they have, and they have the experience they say they have, and you don't have to do a whole process for this as well. So these are some examples for identity for people. But we want to go beyond that. We really want to go to identity for organizations as well. But this is also pretty standard in the identity world. So examples here could be like providing those credentials that I've mentioned before, such as the Know Your Customer data or certificates of authenticity. So that could be like, this is really a processor from Intel, or this is really a computer from Dell, or this is really the bag from a very particular brand. So yeah, you can really prove that the brands are real and combat fraud that way. But you could also sign repairs, like a car repair or a laptop repair, and really have a provable history of what happened to an object. As I explained before, you can have a better user experience for your customers that are signing up. Very importantly is also that the data responsibility can now be put back at the customer level, because I no longer need to store all this data about my customers, because I can just ask them, hey, um, can you give me permission to access your data whenever I want? And then when I need this data, I read it directly from like a little server they have set up, and I read it out, I use it, and immediately delete it again. So the burden of data responsibility goes to the customer, and I no longer need to spend millions of dollars on database protection. I don't have to spend millions of dollars of fines, because a lot of companies unfortunately break the GDPR ruling. But this one is basically the ultimate expression of how GDPR can be implemented. And yeah, a little other idea would be verifiable invoicing. We have some fraud instances where someone pretended to be a company and just send an invoice to other companies and they just pay for it because nobody checks those things. So yeah, that's the use cases for organizations. But IOTA is made for IoT, and we really want to set a step in that direction as well, where we provide identity for things. And you can think about like IoT security. So who has access to an IoT device? Well, I can maybe prove that I'm the owner of this device and therefore I have access. But I could also have access to the data of this IoT device. So you could also have provable qualities. So if you have an idea of how our industry marketplace works, um, it's basically that devices can bid for a specific task to be done, and the lowest bidder, for example, could be accepted. But currently, the devices don't really prove that they have the capabilities of doing this task. So, for example, an automated car that can drive on its own could prove, well, I have sittings for 4 people, I have a charge for the next 500 kilometers, so yes, I can bring you to your location. And these are all like signed properties from the original car manufacturer. So that really increases the trust in the industry marketplace as well. So other ways are, yeah, really enablers for smart cities and supply chains. So you can really trust the data that comes from an IoT device because they have their own identities and they sign the data with these identities, which makes this data more trustworthy because you really know, all right, this comes from a car. Or this comes from a Raspberry Pi, another Raspberry Pi pretending to be a car. So therefore, these identities are pretty strong. It can also start to negotiate between devices or between devices and people very strongly because you can identify who they're owned, what they are doing, what kind of data they have. And when you can start trusting this data, then a lot of use cases are enabled in smart cities and supply chains. So the last part I would like to talk about is kickstarting the ecosystem. So the whole idea of identity is very nice, but just like any other application, we have a chicken and egg problem. We also see this with IOTA in general. You need users before people will start making applications, but you need applications before people start adopting it. So this chicken and egg problem here needs to be resolved. And we as an IOTA Foundation have the responsibility to do this, but we would like to activate you to take part in this and find a place in this ecosystem. And this can be completely to your own benefit as well. So what we would like to do as the IOTA Foundation is making onboarding as easy as possible for both the users, but also the application makers and companies that want to adopt this technology. So we also want to have a very easy to use code base. And we want to create tools and basic applications to allow you to use your identity, to really build your identity use cases. And one of the ways we do this is by having started this Tangle working group called Eclipse Unified Identity, where we hope to do exactly these kind of things. So you're always welcome to join there as well. And we would also really like to foster the ecosystem to produce enabling products such as the ION, as I mentioned before, but also other startups that are busy with identity on IOTA and providing services. So we have this whole ecosystem that we want to have to fill out, and I made this pretty awful graph of like key components that need to be made. The red ones are definitely part of what the IOTA Foundation does, and the other ones are parts that the community can pick up or other businesses can pick up, as these have valid business models as well. Yeah. So the users and the corporates are basically two sides of the puzzles here, of the puzzle. So users need to be able to create an identity, manage it, store their data somewhere, and decide how they share the data with whom. So providing consent. And this needs to be a very easy application that people want to use. And at the same time, corporates need to have software for accepting these identities and build it into their system. So you probably need like customized software for this as well. And this can just be done by many different companies that are specialized in our technology. So another thing that we've been working on is a project we call Self. This is basically a demo platform for identity use cases or a proof of concept. It's a standalone app which people can download soon, and they'll be able to get credentials about themselves and can share them with other parties. So what we would like to do is build multiple demos on this platform showing the advantages of identity. So little spoiler ahead, one of the demos that we're building is being able to prove or open up a bank account in seconds because you can already prove who you are instead of it taking days or weeks as is currently being done. And we provide this basically as a narratives as a service. So what you can do as a company is decide, well, I would like to know how can identity have an impact on our business. Then you can come talk with us at the IOTA Foundation, and we'll have a look at giving you a demo of what kind of impact it can have on your business models and your business in general. Other things we're doing is we have Identity TS, which is a TypeScript implementation of the Unified Identity Protocol, but we want to move towards Rust to provide a real production-ready identity protocol. We already released a white paper, which you can find online, which is called A Case for a Unified Identity. And we've started the working group that I mentioned before under the Eclipse Foundation. That's the work that we've been doing so far. I would like to thank you for your attention, and please feel free to put any questions in the chat and we'll try to answer them as soon as possible. Thank you very much.
Hey, thanks, Jelle. So there are a few questions that came in. Thanks everybody for asking them. We'll try to answer all of them. But first, I need some help because there's something that has always bothered me about my digital self. Who am I online? Am I my identity? What does the DID do for my real self? Is this all the same as having a digital twin? Help me understand this, please.
Oh, you're not making it easy for me immediately. Um, so you are not necessarily directly your digital identity or your DID, but we're trying to make the couple as strong as possible. It's very important that the DID actually does represent you so that your identity cannot be stolen or that nobody can be fraudulent about it. Um, However, this link, we can only prove it by the fact that I can prove that I am the owner of a private key. So really my digital identity is nothing more than proving the fact that I'm the owner of the private key associated with the DID.
Well, wait a second. Private key and public key. I know what they are, but maybe not everyone who's watching this does. How are they different? And I mean, which of those can I share? And how do I do that?
Yeah, so the public key, you're completely welcome to share, but the private key you should never share. It's a little bit like a bank account and a PIN code. So a bank account number you can freely share. So if someone wants to send money to you, you can send it to someone and they know how to identify you. But if you want to prove that you're the owner of this account, then you use your PIN code. And the public key and private key are very similar to this. So the public key is actually the like your bank account, you can prove that you're or that is an identity, and the private key is used to sign a message that can be verified using the public key, so that there's a link between them. Only the private key owner can sign this message, which can be connected to the public key. And since the public key is linked to the DID, there's the whole link to how it connects you to your DID.
Ah, so you're saying that I publish my public key on the DID and maintain a secure holding of my private key, and that's how we. I mean, not Majid asked it maybe better than I can ask it. They asked, so what do you mean by saying no private data is on IOTA, and how is this GDPR CCPA compliant?
Yeah, so are we GDPR compliant? Well, we like to really believe that, but the interpretation of GDPR is you can do lots of interpretations on it. And we're trying to be GDPR compliant according to the most strict version of it. And there's no way to really guarantee that because we don't know how lawyers going to interpret that. But the big question here is, will DIDs, which are identifiers, be seen as a GDPR violation because it could be personable, identifiable information? And the identifiable here is important because DID is an identifier. Um, However, we're trying to mitigate that as much as possible. So this DID and the public key are posted to IOTA. However, no other data ever is put on IOTA using any format. So no hashing of personal data such as your name or anything like that. So your actual information that you care about is never put on IOTA in any format. So therefore, we believe that we're GDPR compliant. Uh, does that answer all your questions? Because you had a few.
Well, it does, but I mean, there's more here. Like, if we dissect this, then what you're basically telling me is that the DID is actually capable of building a component in a zero knowledge proof because I get to choose what I share with people. You know, this whole driver's license example where I don't need to show the bouncer my address and my name. They just need to know how old I am in order to enter the bar in 2029 when they open the bars again.
Yeah, sorry, I didn't catch the question in
Well,
that.
I mean, the question is more reinforcing my understanding that we are not revealing actually personally identifying information. We're only signaling that there is information there. It's up to to the end user to decide with whom they share that data. Am I right?
Exactly. Yeah. You decide who you share your data with and how. And indeed, the identity is just a way to prove that you're the subject of this data, the owner of this data. And since this data is about a person, you're basically just sharing your data in that way. And the data is always very strongly linked to the DID. So you must always prove ownership of the DID before such data should be accepted. And to reference back to your zero knowledge proof, that is indeed the best way forward. With IOTA, we're trying to focus as well on disclosing the minimum amount of information possible in all these cases. So, for example, in the self demo platform, we also show that every time that someone asks you to share information, you can always see what data they ask for. So you could decide, hey, this is too much information. I don't want to share all of that with you. And yeah, that's how you really can keep control of your data.
You know, Majid asks a very interesting question here too. Not just, how do we share this with people, which is obviously interesting, but more specifically, is there a limit to the size that a DID can grow to, or is that irrelevant for our use case here?
So first, how do we share? The identity protocol that we've written at the IOTA Foundation is actually completely separate from the communication layer. One way I could share my data is I can generate a QR code from my, let's say, digital driver's license, and the other person can scan that. So the information is shared through the QR code to the other device. But there's nothing stopping me from building another communication layer through Bluetooth or NFC or even over IOTA, although there you get into problems with GDPR. But this is very valid for IoT devices to share their data over IOTA. And sorry, what was the second part of that question?
Well, I mean, the question goes on to talk about how how large can these DID documents grow to? I mean, if we're putting lots of information in them, I mean, let's just step aside from the human identity and talk about, for example, as Oliver asks, what about things that are common knowledge, like, for example, the title of a magazine and the publisher and that kind of information. If it's not personally identifiable, it could be put inside of the DID, and therefore, is there an upper limit to the size of this, or is the sky the limit?
Well, with IOTA, since we use free transactions or feeless transactions, and we currently have bundles, there's basically no real upper limit to how big a DID can grow. For every transaction that you put on IOTA, you have to do a little bit of proof of work. So there's a slight cost for you. So if you create a very large DID, it will take a little bit longer before it is properly put on IOTA. So that's your own risk there. Um, but what you describe are basically also public credentials. So information that a company or an IoT device wants to be shown as public about them, you can definitely reference those in your DID document. And that's where we can use the service endpoints for. So what I could do is say, this is a DID document, and this is from a organization, and you can find the full information about the organization, like the address, the name, maybe any more legal information on this other IOTA address. So it just links to that. So the DID document stays relatively small, and you can then basically reference to an IOTA streams part, which describes your information, which you probably have digitally signed using your DID again, because it can really be seen as a way to prove something that it comes from you. So this way, you can compartmentalize what data you want to have about you and directly put it on IOTA without growing your DID document all too much. But technically speaking, there's not really a limitation there. But I just wouldn't advise like making a 10-page or DID document.
I see. So what you're recommending is that the DID document itself is kind of like a verifiable fingerprint, and it's not the DNA of the entity it's representing. That's held somewhere else, perhaps on the Tangle, or in the case of health data, potentially in an audited and secure database that's managed by a government provider or something, right?
Yeah, definitely. That's a very good way to explain that. Something I would like to add there, because that's interesting, is that you mentioned storing the health data somewhere like government backed. Personally, I'm quite a fan of actually storing your own data locally. So maybe in a few years, I'll have a device in my house which really represents me, my personal agent, and that stores and manages my own personal information. And that way the data can be shared by giving someone a permission, like, hey, you can see this specific data, and then the device, they can present that data to the device and receive the data. So they can request this at any time. I don't have to actively monitor this continuously. Like, I've given my bank access uh, to my where my house is, because they just need to know that from time to time. And using this, they don't really have to store this information on their own databases anymore. So
Okay,
that's maybe a way. Yeah, go ahead.
but what if I lose my well, TFMC is asking, what if I lose my ID? But what if I lose my private keys? What if my device gets stolen or burned and destroyed? How do I prove I am who I am supposed to prove I am? How does that work?
Yeah, that's one of the more complicated questions that we're still trying to figure out and have a great answer for. Currently, there are just some workarounds. So, a digital identity should actually be relatively easy to recreate. I gathered a few credentials from companies, so I could just come back and say, "Hey, you can see me in flesh and blood, so you know it's really me. Can you create a new credential for my other digital identity because I lost the previous one?" This is a way you can recreate it. But it's obviously not the process that we want to go through. So, one way of doing it could be by storing a backup, an encrypted backup in a cloud environment, or you can, for example, distribute a second private key, which you can use to restore your DID, and yeah, cut it into small pieces and then distribute that among some like trusted friends and family in their app, so that if you ever want to recreate and re- take charge of your identity again because you lost your phone, you can ask like 3 out of the 5 friends to provide their pieces, and you can recombine that to restore control over your identity. But it's definitely a problem that still needs to be solved, like fully or correctly.
But isn't it the case that I could revoke my public key over the Tangle and just say, "Hey, that's no longer who I am"?
Yes, you can always retract your own information. Like you could just destroy your DID. There's nothing against that. That's actually a feature. And the same goes for companies. They can retract information that they've said about you. Um, yeah, that can be relevant for when you lose your identity or when they no longer find something valid about you.
Okay. Well, now I've got the very last question because we're about to run out of time, but it's a big one. And I think you kind of talked about this very briefly a little while ago when you were talking about maybe in 5 years. So, in your opinion, in 5 years, what industries do you think are going to be impacted to the greatest degree by something like unified identity?
Um, yeah, you can. So there's basically the question as well: will it be the identity for people or the identity for things that really goes through? In 5 years, I believe there's actually a chance that both of them will be doing well. But the biggest impacted industries are probably, let's hope in 5 years that smart cities will be getting there. I think government infrastructure and interacting with that in a trusted manner will definitely be impacted by this. Um, and also really the world of IoT. It's still very much upcoming. I don't think IoT is used as often as we want it to, but really being able to trust devices as they communicate between each other and identify each other should really open up more use cases and create more trust in those devices. Being able to manage them better, protect them better, because security in IoT devices is also still problematic. Yeah, I do believe that there's a large impact there. And then lastly, in supply chain, there's also lots of possibilities with identity. Um, but on the problem with supply chain is that you basically need to have everyone in the supply chain involved. So really getting that together in 5 years with this still growing technology that needs to be proven, like identity, that's going to be tricky. But yeah, smart cities, possibly supply chain, and the IoT world.
Wow. Well, I really feel like a lot of my uncertainty about digital identity and a unified identity and the DID has been supported by this webinar, and I really, really appreciate your time, Jelle.
Thank you very much. Yeah, I appreciate the excellent questions, also from everyone in the chat, of course.
Right. So thanks everybody for coming to our fourth webinar, and to thank you for your interest and the time that you've spent with us. You will each now get access to a certificate of attendance from our live session, securely published and stored on the IOTA Tangle. You will receive a link to download your certificate from the Tangle in a follow-up email after this webinar. So for now, be sure to register for next week's session where we will talk about the role of digital assets and the IOTA token economy. We'll post the sign up link in the description of this video. And speaking of which, please, please be sure to like this video and follow us here on YouTube. It really helps. Also, if you want to learn more about IOTA, feel free to reach out to us over any of the channels in the follow-up email that you are about to receive. Personally, I'd like to thank our awesome technical crew, Dave and Tara, for putting on a great show once again. And finally, expand your DLT knowledge and find trainings for IOTA on training.iota.org. Run together with the official learning partner of the IOTA Foundation, namely the IoT One Academy. Get unprecedented access to IOTA onboarding courses for developers and managers to quickly gain broad knowledge about IOTA and DLT in general. Enjoy amazing learning content co-authored with the IOTA Foundation. Please visit training.iota.org. Stay safe, everybody.